the equation here. X squared minus 4 times the absolute value of x minus 5 equals 0. So first, for x less than 0, you're going to have x squared minus 4 times the negative of x. So you drop the bars, you put negative x. That's how you take the absolute value when x is less than 0. And then minus 5 equals 0. So that's going to give you x squared plus 4x minus 5 equals 0. Then you just factor here. So the numbers that multiply to negative 5 add up to 4. So x and x, it's going to be 5 positive and negative 1. Product is negative 5, sum is 4. So x is negative 5 or x is positive 1. Now remember, we have x less than 0, so this one has to be rejected for that reason. It's an extraneous solution from dropping the bars and all that. In other words, like this part here, if you just graph it and see where it's equal to 0, you just basically have it goes through negative 5, which is okay here, but it also goes through positive 1, right, which is bad for our purposes. Okay, when x is greater than 0, we have x squared minus 4 times x, so you just drop the bars and just put x directly, minus 5 equals 0, so you're going to have, again, just factor this, like that, right? So, let's see, x minus 5, and then x plus 1, product is negative 5, sum is negative 4. So x is 5 or x is negative 1. But again, we got to remember that this is greater than 0, so this one has to be rejected. And this is acceptable one. And again, why does this happen? Because this is just a quadratic, and you're saying, where does it equal to 0? You've dropped the bars. Doesn't remember that this was originally something with an absolute value. So, like if you graph the left-hand side, it goes through negative 1 and it goes through positive 5. So this positive 5 right here is okay, but where it's equal to negative 1 there, that's bad, right? This is bad, and the same thing over here, this was bad. Lastly, if you graph like this equation, x squared minus 4x, an absolute value minus 5 equals 0. If you graph the left-hand side and you see where it's equal to 0, the x's, it looks like this. It goes through negative 5 as a cusp, and then bounces back and then goes through positive 5. So we have identified the correct values, right, by using 5 and negative 5 and skipping negative 1 and positive 1, which are introduced as extraneous solutions. If you like these types of videos, please be sure to leave a like and subscribe.